Hello everyone, I'm Tu Hang Fung from Hanoi University of Science and Technology. Today I will present our work on federated prompt tuning with heterogeneous and incomplete multimodal client data in collaboration with EPFL, Griffith University, and Washington State University. First, let me briefly explain federated learning. It's a decentralized paradigm where multiple clients train a shared model without sharing the data. Then, a central server will get the updates and share back the weight to the clients. However, most federated learning setups assume all clients having the same data type, such as only image or text. In practice, data often comes from multiple modalities like images and text, but missing sensors create various data types like single modalities, complete, or partially missing. Building on the fact that foundation models like vision language transformer are effective for multimodal data, so we give each client a pre-trained vision language transformer. Since client data varies, we design the model and aggregate so the global model still performs well, even on incomplete data, which is we want the performance to be as close to the complete data as possible. But solving the problem leads to two key challenges: is intra-client heterogeneity, where each data sample may have different missing modalities, and inter-client, where each client observes a different distribution of missing types. Most prior work addresses only one of these, but to make multimodal federated learning truly practical, we need to address both simultaneously. Therefore, we propose FedPrime, a federated prompt tuning framework built on top of the vision language transformer backbone. Each client learns two types of prompts: intra-client prompts, which capture the general patterns of missing modalities across samples, and inter-client prompt, encoding dominant missing data patterns shared across clients. These prompts are selected from a learnable pool using key query similarity so that each sample retrieves the most relevant instructions during training. After local training, intra-prompts and classifier heads are aggregated using FedAverage, but inter-prompt requires special treatment due to their semantic sensitivity, which I'll explain later. To ensure meaningful prompt selection, we use a contrastive loss. It encourages the selected prompt to be close to the input query vector in the embedding space, while pushing away irrelevant prompts. The final loss combines the contrastive loss with the downstream task loss. Inter-client prompts can be averaged because their positions may encode different semantics across clients. Instead, we perform semantic clustering on these prompts using a learnable alignment mechanism. Similar prompts are grouped and replaced by the cluster centroid, forming a global summarizing prompt pool. This strategy avoids collapsing diverse instructions and enables the model to generalize better across clients with different missing patterns. We evaluate FedPrime on two multimodal datasets, Food 101 and IMDb. And across all missing modality scenarios, FedPrime consistently outperforms strong baselines like FedAverage, FedMSplit, and our own applications. In some cases, we observe over 100% relative improvement compared to the second-best method, and this also confirms the necessity of handling both intra- and inter-client heterogeneities. To understand why our method works, we analyze the loan embeddings using Disney. FedAverage results in 3 separated clusters, one for each missing modality case, indicating that its prompts encode overly specific signals. In contrast, FedPrime leads to a more unified embedding space across all sample types. This alignment helps the model perform well even when some modalities are missing. We also test Fed prime in label-secure non-ID scenarios. Here we compare against FedBlock, and even in this challenging setup, Fed prime still outperforms FedBlock thanks to its inter-clan prime alignment, which distills shared knowledge across diverse clans while still preserving privacy. That's the end of my presentation. If you're interested in the details, please take a look at the full paper. Thank you for watching.